Hello viewers, today our topic is data interpretation. So data interpretation, usually in any exam they'll ask you three or four questions depending on the number of questions. If it is 25 questions exam, they may ask you about 3 to 4 data interpretation questions. If it is about 100 questions, they may nearly ask you up to 8 to 10 data interpretation questions. So it holds very importance in your exam. So what kind of data interpretation questions you may get? So data interpretation questions will be various types. They may ask you data interpretation questions based on bar graph, or else a tabular graph, or else pie charts, or else a line graph. So what we are going to do in this session is first learn the concepts of data interpretation. So the concepts of data interpretation means how do we actually interpret the data when a bar graph is given, or else when a pie chart is given, or else when a line graph is given, or else a tabular graph is given. How do you look at the values, and what are the things they usually ask you, and what are the basic formulas you should have in handy in order to solve your data interpretation question. Suppose in the exam, if you get completely unknown data interpretation questions, you cannot actually interpret the data if you don't have any prior experience with that graph. So if you already practice that graph, what happens in the exam is you exactly know where to look for the data. Otherwise it is not possible for you to look at for the data in the exam. So in the given time, you don't have that much of time to interpret the data to understand the graph completely. So first, concepts of data interpretation will be definitely helpful in order to know the basics and the formulas that you need to have it handy. So we'll start with data interpretation is all about the combination of averages and percentages and somewhat ratio and proportions. So how you use your averages in data interpretation and percentages in data interpretation and ratio proportions in data interpretation we are going to look at now. First, the concepts of averages in data interpretation. When various data is given to you, suppose let's say there are 5 companies A, B, C, D, E, produces cars in terms of thousands or millions, it doesn't matter. Let's say the values are 153,000 cars. Let's say 147, 155 in terms of 1000, 162, 135. All the values are close to each other. If you look at, these are the 5 companies, number of cars produced by 5 companies, all the values are near to or close to 150. When these kind of data is given, how do you find out? If they ask you what is the average number of cars produced by the 5 companies given, in terms of 1000 or lakhs or millions, it doesn't matter. But all you have to look at, because mostly in data interpretation all the values given are close to each other. They don't give you values with a much dispersion, they'll give you with a lower dispersion, which means the difference will be less. I'm assuming the data, take any number which is in between. 135 is the minimum number given, 162 is the maximum number given. So take any value which is in between 135 to 162 and let the value be round figure so that you can easily do it. I'm assuming it as 150. Let the average is 150. What happens? Look at here, subtract this 150 from each and every observation. 153 minus 150, it is 3 here. This is minus 3. I am finding the deviations. You call them deviations. So this is 12, this is minus 15. My assumption was 150. Now look at the deviations here. What is your deviation? Sum of deviations, you do it. 3 minus 3 get cancelled. 12 plus 5, 17 minus 15 is plus 2. These deviation will affect on all 5 observations. Therefore 2, you divide it by all 5 observations. We know 2 by 5 gives me 0.4. So the average of all 5 observations is 150.4. Suppose your sum of deviations is 0, then your assumption, your assumed average, here 150 is your actual average. If suppose your deviation is negative, then you have to subtract the value and divide it by what? 5. If it is positive, you just need to add it. If it is negative, you just need to subtract it. If it is 0, then your assumption is nothing but your average. Now, what is the reason behind this? Why we are taking these deviations and dividing it by 5 also I will tell you. Now, one more thing to learn here. If I ask you what is the total number of cards produced by A, B, C, D, E. In the exam, adding this 3, 7, 5, 2, 5 like 153, 147 odd numbers are there. So, adding this will take a lot of time, but if you go with the assumption again, assume that 150 is a closer value. I am taking out 150 from all the other numbers. 150 into 5. I am taking this 150 5 times. So, therefore, 150 into 5 gives me 750. Then after it becomes plus or minus depending on the deviations. So, here you got positive deviation of 2, just add it. So, you are getting 752 sum of the data. So, sum of the data is 752 there. Now, what is the reason behind taking all of them? If I ask you average of all this, how do I write it? I know I will write it as 153 plus 147 plus 155 plus 162 plus 135 divided by what? 5. Because we know average of certain observations is equals to sum of observations by number of observations. Now, I am choosing my average as 150. Therefore, I can write each and every observation as, first observation as 150 plus 3. Second observation I can write 150 minus 3. You understand the deviations? So, deviations comes from this value plus 5. 150 plus 12. 150 minus 15. So, 150 came 5 times. Therefore, if you want to find out the sum of data, you can say 5 into 150. Now, sum of deviations if you do, you will get plus 2. So, here if you only look at the numerator, if you look at only the numerator, you can just find out the sum in the same manner. You understand how do we do the sum here? Okay, other than adding 5, okay, these 5, 2, 5, 7, 3, we are going to do it directly like this. Now, we are going to find out the average. So, 150 comes, 5 by 5 get cancelled, 150 plus 2 by 5. What is 2 by 5 here? 0.4. So, this is extremely useful when you solve a data interpretation question, especially in a tabular graph. When values are given and which are close to each other, you can find out the sum or else the average of the given numbers by using this logic. So, here your averages logic is useful. Then after we will go for percentages. Now, how your percentages is useful in this? Look at the percentages. What are the basic formulas in percentages? X percent of Y. We all know X percent of Y or Y percent of X. It's always X into Y by 100. In percentages, always remember order does not matter. X percent of Y or Y percent of X is simply XY by 100. X is what percent of Y? X is what percent of Y or else what percent of Y is X? In both the ways the answer is same. You are comparing X with Y. So, X should be in the numerator, Y should be in the denominator into 100. So, X is what percent of Y or what percent of Y is X? It is X by Y into 100. How can they ask you these kind of questions in data interpretation? You may have this doubt. They don't ask you X and Y. They give you data. For example, I am taking the data from 2015 to 2020, 2015, 16, 17, 18, 19, 20. Now, they'll ask you like this. Data in 2015 is what percent of data when compared to 2020? They'll ask you to express 15 is what percentage of 20. Let's say you purchase certain, factory produces certain number of cars in 2015 and certain number of cars in 2020. they'll ask you number of cars produced in 2015 is what percent of number of cars produced in 2020. In terms of percentage, when they ask you, when they compare one value with the other in terms of percentage, then you can always use this formula. XC is what percent of Y, or else what percent of Y is X. The second one also they may ask you how. What percentage of the cars produced in 2020 is equals to cars produced in 2015. So here is your X is nothing but cars produced in 2015. Y is nothing but your cars produced in 2020. This 2015 and 20 is I am taking it. Okay. So this is just purely an assumption. If you want to increase the number by X percent, increase number N by X percent. So what do? You simply multiply that X, multiply that number N with 1 plus X by 100. You multiply that number with 1 plus X by 100, therefore the number increases by X percent, or else you can say 100 plus X by 100 into N. This is increase of a number by X percent. If you want it more in detail or more shorter way, then you can go for the basics of percentages which is explained. Now, suppose if I increase a number by 20%, I want to increase any data by 20%, you multiply that number that you wish to increase by 20% by 120 by 100 into that number. Same is the case with decrease. If you want to decrease the number by X percent, if I say X percent decrease, all you have to do is 100 minus X by 100 into that particular number. So first we have seen X percent of Y, X is what percent of Y, then X percent increase and X percent decrease. If they ask you to increase any number by X percent, or if they ask you to decrease any number by X percent, you can do this. Then finally, the most importantly, percentage increase or percentage decrease. Percentage more, less, or same as percentage increase and percentage decrease. How do I find out percentage increase or decrease? Suppose I'll take an example here. Let's say 120 becomes 150. If I ask you, see, generally how do I find out percentage increase here? I say value increase is 30 divided by initial value is 120 into 100. You say 1 out of 4, that is 100 by 4, 25%. So the normal formula for percentage increase, numerator you take value increased by you take initial value into 100. This is the formula for percentage increase. Now percentage decrease also, you take value decreased by initial value into 100. See, percentage increase is same as percentage more. Percentage decrease is same as percentage less. So in data interpretation, these kind of questions can also be asked. Data in 2020 is what percent more than data in 2015? Or else when you compare from 2015 to 2020, data is increased by what percent? Or data is decreased by what percent? Or else data in 2015 is what percent less than the data in 2020? Always remember, percentage more means percentage increase, percentage less means percentage decrease. Remember that. If I ask you, X is what percent more than Y? Now in place of X and Y, they'll give you other two statements. In place of X, they may give you data in 2020 or whatever the data, cars produced by company A, cars produced by company B. Those things also can be asked. So X is what percentage more than Y? So here we can clearly see X is more than Y. Okay. So I would say actually it was Y, but it became X. Percentage more means percentage increase. What is the difference between them? The difference between them is X minus Y, because X is more than Y. You are comparing it with Y. So therefore initial value is Y into 100. The formula is x minus y, the difference by initial value into 100. Initially it was y, so it is becoming x. So x is what percent more than y. If I say x is what percent less than y, x is what percent less than y, then you can say now lesser than y, therefore y is greater, y minus x, but again you are comparing it with y into 100. Therefore actually here also y becomes what? X. But here less means y is decreasing. What is percentage decrease? Value decrease by initial value. Here also initial value is y itself. Therefore y minus x by y into 100. So percentage increase or percentage decrease, percentage more or percentage less, both of them are same. So this is how they'll ask you. Now see here, I'm just taking the data in 2015, 2016, 17, 18, 19. Let's say the number of cards produced in 2015 is just 1000 cards. In 2016 it became 4000 cards. In 2017 it became 12,000 cards. 2018 it became 24,000 cards. 2019 it became 40,000 cards. Everything is in 1000, 2015 to 2019. If I ask you in between which two successive years, the percentage increase is the greatest. The percentage increase is the greatest in between which two successive years. If you go by only the value 24 to 40, it is 16,000 cards added which are in between 18 to 19. So if you go by the value, 16,000 is huge, right? From 18 to 19, 16,000 cards increased. Therefore, but the answer is not. You cannot say that it is in between 18 to 19. Options are what? In between year 15 to 16, 16 to 17, 17 to 18, 18 to 19. In between which two successive years the percentage increase is maximum. Now here he is asking you the percentage increase, not the value increased. Now see here how much it is increasing. It is 3 upon 1 into 100. When a number becomes 4 times, the percentage increase is 300 times. When a number triples, percentage increase is actually 200 times. Or else you can take 8 increase upon 4 into 100, that is 200% from 16 to 17. If you look at from 17 to 18, when a number doubles, which means it is 100% increase, it is not even double. The percentage increase is actually less than 100. So don't look at the value, look at upon which it is increasing and upon which it is decreasing. That is very, very important than the value. If you look at only value, okay, there is a chance that you may go wrong. Okay, so I am giving you values here. I can actually give you in terms of bar graph also. Let's say if I give you bar graph like this. I'm going to say this is data in 2015, same thing 16, 17, 18, 19. Something like this. This is just 1000. Let's say it is 4000. Now this one is 12,000. It's 24,000. So I'm just adding the data a little further. This is 40,000. In terms of value, if you look at, let me write the values here. It is 1, 4, 12, 24 and 40. In terms of value, if you look at it, is 16,000 increased. But in terms of percentage, how much percentage increased? 300%. So how much increase doesn't matter, upon which it is increasing matters. Okay. When you are looking at percentage increase, upon which it is increasing, what is your initial value matters. So in between 18 to 19, it may increase 16,000 or else 16 units, but upon which it is increasing, upon 24, so it is not even 100% there. So be careful when you do percentage increase and decrease. It is not about values increase and decrease. They will ask you percentage increase and decrease. Now after this, you have ratio proportions also. How ratios will be useful in your data interpretation? So ratios, you should be ready to factorize the given numbers. Suppose I am asking you to divide 126 in the ratio 3:4, or else I am asking you to divide 136 in the ratio 9:8, in the ratio 5:2, 91 in the ratio 6:7. Now, how do you divide the given numbers in the given ratio? So, without wasting time, in mind always assume 3 plus 4, there are 7 parts in this ratio. This 7 parts is equals to 126. When 7 parts is 126, you should be able to factorize the given number 126 quickly. 126 is actually 18 sevens or 14 nines. Here, the suitable one is actually 18 sevens. The moment you look at 18 sevens, 7 parts is 126. Therefore, I can say each part is 18. In your mind, you should do this, not on the paper, but in your mind. 7 parts is 126. Therefore, one part is just 18. If one part is 18, I have to divide it into 3:4 ratio. 3 18s are 54. 4 18s are 72. So, this is how you must divide it. Now, 136 is actually 17 eighths. Therefore, 17 parts, each part is 8. 9 eighths are 72, 8 eighths are 64. This is how you need to divide. 7 parts, 17 is each part because 17 sevens are 17 fives are 85, 17 twos are 34. This is how you must divide it. 13 parts, each part is 7, 6 sevens are 42, 7 sevens are 49. So, ratios will help you to divide the given number in the given ratio. But in order to do so, you need to be perfect with all the 20 tables. So, learn 20 tables to and fro. When I am saying to and fro, the meaning is when I give you 144, you should be able to factorize it quickly. You should be able to say 18 eighths, or else you should be able to say, you can also say this 16 nines. So, learn how do we factorize the given number, because it's all about numbers. The more you practice, more you can remember about the numbers. Now, we'll see a specific graph called pie chart. So, how do we actually deal with pie charts? Because all the other line, bar and tabular graphs will be covered in averages, percentages and the thing which I said ratios. But when it comes to pie graph, you should learn some basics. Now, look at here. Pie graph is actually a circular graph as shown in the given figure there. Now, a pie graph consists of 360 degrees. If I take the data which is given here, complete data is 360 degrees. But if I take it in terms of percentage, it is 100%. So, 360 degrees is taken as 100%. How do we convert percentage to degrees and degrees to percentage? We know 360 is 100%. So, what is 1 degree? We say 100 by 360, which is actually what? We'll multiply it with 5 by 18. Same as your time and distance. Okay. But the easiest way I'll tell you, take it as degrees and percentage. Remember two tables here, one is 18 and one is 5. 18 table is very important in terms of your data interpretation and as well as in your time and work. 18, 36, 54, 72, 90, 108, 126, 144, 162, 180. I want you to know each and every number in 18 table. It will be very helpful. The moment I give you 162, what should come to your mind? 18 nines should come to your mind. The moment I give you 108, what should come to your mind? 6 should come to your mind because 18 6. Now, take percentage. It's 5. Take a multiple of 5. 5, 10, 15, 20, 25, 30. 35, 40, 45, 50. Now, respective multiple of 5 also you take it. Suppose if I give you 72 degrees, in mind 18 fours are Therefore, do 5 4s are 20%. So 72 degrees means 20%. If you know 5 table and 18 table perfectly, you can do this. So 162 degrees, you can say 45%. Because you have 360 degrees, which is 100%. If I take 360 degrees, it is 100%. Take 36 degrees, it will be 10%. Okay. If I take 3.6 degrees, it is 1%. Like this also you should know. Okay. So here two tables will help you. One is 18 and 5. You should be able to quickly convert. 126 degrees is actually 7s are therefore 7 5s are 35. So it is 35%. So this 18 table and 5 table will help you to convert degrees into percentage, for percentage into degree. If you can't convert every degree like this, but definitely a degree which is a multiple of 9 and 18 you can definitely convert. Remember 18 is 5 degrees, therefore 9 becomes 2.5%. Okay. If I have 99 degrees, 90 means 25, 9 means 2.5. So you can say 27.5%. If I have 81 degrees, you can say 72 plus 9, 72 is 20, 9 is 2.5. Therefore 22.5. If I have 45 degrees, you can say 36 plus 9, 36 is actually 10, 9 is 2.5, therefore it becomes 12.5%. So this is how you convert the data. And finally, how proportion is useful in this? They'll give you 360 degrees to 100% to some data. Let's say the cards produced is 1500 cards. Your total cards that you are producing in that pie chart or representing in pie chart is 1500 cards. Now if I give you only 72 degrees is how much percentage? Then you cross multiply. Or else 72 degrees, how many cards? You cross multiply this and this. So by using that proportional, you can always find it. But the relation is 360 degrees is 100% is the number of cards or whatever the data which is represented. So you can convert degree to percentage, percentage to the data. So anywhere given by using the proportion. So far in the video, we have seen how do we actually tackle data interpretation by using the basic concept percentages, averages and ratio and proportions. And we have also seen what is percentage increase and percentage decrease and how it will be useful in your questions, and also some basics of pie chart so that you can quickly write down degrees to percentage, percentage to degree. It will help you to solve the questions quickly in the exam. So in the next class, we'll look at each and every graph clearly. Thank you.